So today we are going to talk about our Leetcode question number 5, longest palindromic substring. So the question says, given a string X, return the longest palindromic substring in X. A string is called a palindromic string if the reverse of the string is same as the original string. Substring, first of all, the substring is continuous. So for the first example, we have BA, BAD, and among all the substring, the longest palindromic substring is BAB. And this one is XCBBD. The longest palindromic substring is BNB. So I'm going to show you a table to see how to visualize this problem. So for example, we have our 38. The string is 38. And first, we need to initialize the table as all truths. And then our starting point is from the diagonal, either from this A or this A or this A. So that would be AMA at the same, AMA at the same, AMA at the same. So that's being said, it's guaranteed to be true if it's in the diagonal. And then we from the bottom to the top to check the right top corner from the diagonal. So for example, we have we are here, we have AMA, this AMA are the same. Now we cannot guarantee the string from this index to this index, this substring from this index to this index will give us a palindromic substring. We need to check the middle string to see if it's palindromic. So that will be, we go one step forward for the I, that will be I plus 1. And then for the J, that will be J minus 1, one step backward. That will be this precision. So we have to know this precision first before we can actually go here. So we need to start from the bottom to the top to fill out the tables. Let's see how we are going to write the code. Let me back to the question. Right. So first we need to get the length of the string first. That will be n length x. And then we need to create a table with size n times n. Choose times n for I in range of n. And then we need to fill on the table from bottom to the top. So let's do it for I in range of n minus 1, because the last entry is the end of the diagonal, so it's already true. So we don't need to worry about that. So we start with n minus 1, and then stop at -1, and then the step is -1. And then for J in range of I, and then oh wait, so never, sorry, my bad. Actually, our starting point is n minus 1 because the size of the table is the length. I mean the rows is n, but we start with index 0 instead of index 1. So we here it has to be n minus 1, and then and then we check if x I equal xj. So if yes, if I equal j is guaranteed to be true, dp I j equal true. Else, if it is not on the diagonal, the position has to match the middle substring. So that will be equal to dp I plus 1 and j minus 1. So if they're not the same, so it means it's not a palindromic substring. So it means it's false. Equal false. Okay. So since at the end we need to return the longest palindromic substring, so we need to like use some variable to store our start point and end point. So let's say our start point 0, our end point is 0, and then the maximum length is 0. Then we traverse our table, DP table in range of end, or j in range of I to end. So we start from the we actually right now we start from the top, and then we only check those position from the from each position from diagonal. Then we said if dpi j equal true, right? And then our temp, it will be the column length, it will be I minus it will be j minus I plus 1. And if the temp greater than maximum length, right, then we update our maximum length equal to temp, and then we need to update our starter point, and n will equal to j plus 1. So at the end, we just need to return answer is equal to x stored and n. Because we need the substring, then we just return answer. Run it. Oh, sorry, it's comparison is double equaled. Yeah, let's run it again. Oh. For I, I'm missing I, typoed. For I in range, for j in range. All right, run it again. All right, it looks great. So you can see BAD. So our longest palindromic substring is BAB. So let's check another case, CDD. Oh, sorry. Yeah, CDD. So CDD, that would be this way because they are all the same. That will perform the longest palindromic substring. So let's submit it. It times out. Yeah, our should be okay. Let's try again. So I'm going to rerun it again. Okay, submit. Yeah, so actually, I don't know why it didn't work. It was set timeout here, but when I resubmitted a few times, it works. And it's actually the same code as before, and made it the system cannot detect it somehow. But anyways, so regarding the time complexity for this question is a bit of n squared because we are checking order, we are like checking order substrings and then store it in the table. So it takes a bit of n squared, and then the space complexity also a bit of n squared. because the size of the table is n times m. Yeah, so that's this question. Thank you so much for watching.